Mostly we talked about how to graph inequalities. Then we talked about how to find our feasible region, find our corner points. Now I'm going to take the next step. Now what I want to do is look at a word problem, and with this word problem set up the inequalities. Because then what we're going to do after this video is we're going to talk about how to solve that finished set up word problem. And then the very last one, okay, we have 2 more videos after this. The very last one, we're going to put everything together. Okay, so we're doing little micro steps. And in the very last video, we're going to put it all together. But let's practice setting up the word problem. Before I go through this problem, let's talk about my process. And if you watched my set up the linear equations video previously, it's going to be almost the exact same thing, okay? The first thing we're going to do is I'm going to skim through this problem so I have an idea what's going on and identify my variables. And that comes from the question. That comes from what am I looking for? That's going to be your x and your y. But here's the extra step with the inequalities. You're going to try to maximize or minimize something, okay? You need to make sure you identify that as well, okay? Now that maximizing, minimizing, whatever you're doing, you're not graphing that, okay? You're going to find that equation and put that off to the side. We'll deal with that later, but do not graph whatever you're trying to maximize or minimize, okay? Then, the last thing you're going to do is kind of make that quote-unquote chart. Line up your x's and your y's in a column, and then we'll just go from there, just like we did with the linear equations. And we'll leave a link in the description if you haven't watched that yet, but it's going to be the exact same process. So let's go ahead and take a look at this problem. What I have here is that a farmer plans to plant 2 crops, A and B. The cost of cultivating crop A is $40 per acre. The cost of cultivating crop B is $60 per acre. The farmer has a maximum of $7,400 available for land cultivation. Each acre of crop A requires 20 labor hours. Each acre of crop B requires 25 labor hours. The farmer has a maximum of 3,300 labor hours available. If he expects to make a profit of $150 per acre on crop A, $200 per acre on crop B, how many acres of crop should he plant to maximize a profit? It's a long problem, okay? This is why I want you to break it down. I just kind of skimmed through it. I just kind of wanted to see what was going on. And now let's go through our process, all right? It's going to make your life easier if you go through this process. First thing, we need to identify my variables. What am I looking for? And what am I looking for is how many acres of crop should he plant? That's your x and your y. I want to make my x my crop A and my y my crop B. Because this is what you're looking for. This is what you're solving for. Now, let's make sure we figure out what am I trying to maximize or minimize. Well, it says here, I'm trying to maximize his profits. Profit is what you're maximizing. Now, what I'm going to do, I'm going to put it way off to the side. That way, I'm not tempted to try to graph it or make it an inequality, because it's not an inequality. Profit is what I'm trying to maximize. And so let's see if I can find what the profit is for crop A and B within the problem. Well, let's see. We make a profit of $150 on crop A and $200 on crop B. So this is going to be 150 times X plus 200 times Y. Okay? That is what I'm maximizing. That is not my inequality. We'll deal with that later. You'll see in the next video how we take that into account. But for right now, let's just leave that off to the side. Awesome. Now that we've identified my variables, now that I've identified what I'm maximizing or minimizing, now let's go back to the beginning and reread each problem, but I'm going to set up my quote-unquote chart where I'm going to have an x, a y, but instead of equals, you're going to have a less than or equal or a greater than or equal to. We don't know yet. We'll have to read the problem to figure out whether it's going to be less than or equal to or greater than or equal to. So let's start from the beginning, okay? A farmer plans to plant 2 crops, A and B. The cost of cultivating crop A is $40 per acre. So for cost, it's $40 for every acre of A. So it's going to be 40 times X. Whereas the cost of cultivating crop B is $60. So crop B is going to be $60, so it will be 60Y. So for my cost, I have 40X plus 60Y. And the farmer has a maximum of $7,400 available. So because he has a maximum of $7,400, you can't get bigger than $7,400. The 40X plus 60Y is less than or equal to 7,400. You cannot get above that because you don't have more than 7,400. All right, so let's keep on reading. Each acre of crop A requires 20 labor hours. Okay, so I'm going to call this labor hours. So labor hours, okay? And crop A, which is my X, requires 20 labor hours, so 20X. Okay. Let's keep on reading. Each acre of crop B requires 25 labor hours, so plus 25Y. Cool. And it says the farmer has a maximum of 3,300 labor hours. So you can't go above 3,300. So this is going to be less than or equal to 3,300. After that, we've already taken the profit into account, and that's it. So your inequalities, these will be your inequalities while you're trying to maximize, P equals 150X plus 200Y. All right? So we've graphed these inequalities, we found the feasible region, we found corner points. In the next video, what we're going to do is we're going to actually solve these inequalities and show you how this goes into effect. And then in the video after that, what we'll do is we're just going to put everything together. We're going to start with the word problem, we're going to set up our inequality, find out what I'm maximizing, graph my inequalities, find my feasible region, find your corner points, and then answer the question. Alright, so go ahead, join us in the next video, and we'll solve a problem like this, and then we'll put it all together at the end.